So today what we covered was prefix sums as kind of a way to answer queries once we have a fixed array. So we had a fixed array, and then we answer queries. And something that we'll see somewhat often in competitive programming is a kind of what's it called? Like a parallelism, I guess. That's not a maths word, but whatever, a parallelism to this, which is instead of this, we have a bunch of updates, and then we have a kind of fixed query. And I'll explain what a fixed query is. So in this case, the array was just a list of numbers, and then our queries were, what's the sum of this range? And prefix sums can be not very similarly, but similarly applied. So instead we have updates of the form, I want to increment this range by a certain number, and I can do that. So instead of Alice asking questions, Alice is telling Bob, this range should be incremented by 1, this range should be incremented by 3, this range should be incremented by 4, this range subtract 1 from all numbers in this range. And then at the very end, Bob wants to know what's the final array. So that's what I'm talking about, the fixed query. It's just what's the final array. So I guess you could say fixed array. Yeah? So do people understand that? If people understand like just what the general idea of this is and how I'm linking it to what we talked about before, can we get a yep or a thumbs up? Oh, hi, Joanna. I didn't notice you were here. Sorry if you were here before. Is it Wise? Hey, Wise? Yeah, thanks. Okay. So if you already know how to do this, maybe you can go to the problem solving room, but I'll explain it now because it's quite interesting. And it actually looks very similar. So as I said, it was parallel in a way to what we discussed before. But in this time, we have our updates first rather than our queries later. So for update, well, I guess for LR in updates. So we're not going to set up a prefix sums thing yet. We're going to have like the opposite of a prefix sum. So we're going to have an array such that the prefix sum is the array, is our actual array. And I guess what I'll call this is, I don't know what to call it. Let's call it Q, because Q is a letter that's similar to P, right? So Q is an array. And then we're going to say the value of R. So if you remember the prefix sum, the idea is to query, we query the final element and the first element. So in this case, instead of querying the final and first element, we're going to update the final and first element. And the reason I'm explaining this now is because it's a bit more weird, I guess. But if we want to update this range, then remember we're creating an array such that the prefix sums will be this array. And if we want to do that, then I guess we take the so I guess instead of the prefix sum array, this Q equals differences in final array. So if we have a simple update like this, if we're updating that range and we're incrementing them by 1, then that will be the final array. And if we take the difference array of this, then we take the difference between this and the previous element, we'll call that one like 0. So that's 0, that's 1, that's 0, that's 0, that's -1. And we can say that even though we had a big range, or a somewhat a small range, but a biggish range, L to R, we can we only have to update two numbers in our difference array, or our Q array, or our inverse prefix array. Okay, I'll rub out that diagram. Sorry if it was useful. I hope it was useful. But I need space. So if you remember that diagram, what we did was QR plus 1 equals plus equals 1. And Grave L. Oh, that's wrong. Let's okay. I'm assuming you know that syntax. Hopefully we're all good with that. But do we see how that diagram from before translates into this? Give me a thumbs up or a thumbs down. That's fine as well. I didn't see Nicole there. Hi. Because I'm screen sharing. My screen's kind of dodgy. Wing and Joanna, does that make sense how this is equivalent to what we just talked about with that picture? And Elliot. Oh, there's a chat. Sorry if I've been missing it for a while. Hopefully I haven't. Okay, good. It was from just then. Good. Yeah, okay. I think some of you joined a bit more recently. So I'll very quickly explain it again. So in this before we had questions. We had a fixed array and then we had questions. What's the sum here? What's the sum here? What's the sum here? Now we're kind of flipping that on its head. We're going to do updates of the form. Add 1 to this range, add 1 to this range, add 1 to this range. And then after all those updates, we want to know what the sum is. We want to know what the final array is. So we could have an update of like, if we have this range, if we have an array of zeros, we could have an update that's like update all of these numbers, update all of these numbers, and update this single number. And then the final array would be that, right? And we want to do that fast rather than just like incrementing all the values in the range using a for loop. So does that explain what the problem was? Just for Wing and Joanna? Yep. And awesome. So just to recap on this line of code, which is kind of the big line, is we want to construct an array such that the prefix sums of that array will be our final answer. And we do that. And kind of the opposite of prefix is difference. So all we have to do to make this range work is to change the difference. So we know that the difference here is going to get bigger by 1 because it gets 1 bigger from that point forward and it stays at 1. So that prefix sum will like kind of preserve that 1 from then on. And that 1 just for this range minus equals 1. So it kind of, that 1 disappears for the rest of the thing. So you get that 1, you keep it for a while, and then it goes away. And it's kind of a property of addition and some other operators that we can kind of stack these things on top of each other. You can prove that if you want. We can stack these updates on top of each other, so they work together. Okay, so to test your understanding, it's not a test obviously, but to check your understanding, does anyone want to tell me how from this we can output the final array? So all we've got is this for loop and the Q values so far. And I guess for Wing and Joanna, I think you were the only people who said that. Does what I've set up to this point make sense now that I've clarified it? Yeah, exactly. Everything. I think you meant Q of L. But yeah, everything except Q and L and Q of R+1 is the same, because the thing that we did to L will kind of propagate until we kind of undo it at R. And I guess that's kind of a hint of how we're going to finish this off. So can people tell me if they're stuck or if they know how to finish this off and output the final array? So currently all we've got is the Q array, but we want to find the actual array once all these updates are performed. If you're stuck, that's fine as well. So our updates are from L to R. So that's the only updates that we're performing. The updates, all the updates, they might start from 1, but they can start from anywhere, right? And the reason that we're doing Q of L here, yeah, sorry, I think it's that crappy thing here. That should be an L. Yep, was that the mistake? So that's an L. That's all. I'll fix all of these up. That's a 1. That's a 1. And all these are 1s, obviously. Hopefully that cleared it up. Are people happy with that? Or do we want me to quickly go over it again? Or do people want to suggest how we recover the final array from this thing here, from the Q values? If you're stuck, can you tell me as well? Yep. Okay, we've got something. So I think, Joanna, is that a suggestion for how to recover the final array, or do you think that that would be more correct than what I've put? If you're able to talk on voice, that'll be really good as well, just because it's way quicker. Yeah. Okay, so maybe it's because I went over it quickly, but I guess I'll just spoil the problem that I've been asking for a bit now. Is we're going to construct, I guess, our original array as a prefix sum of Q. So I guess I can go back to that slide, but it's that yellow circled line, if you can see it as yellow circled. So we pretty much just compute that prefix sum array. Instead of A, it's Q. And then, so what have we done? I'll give you an example. I'll rub this stuff out. I'll just use a new slide. What is an empty slide? That's fairly empty. I'll just use that. Okay. So we have our array, and this is Q, and some guy comes up to us, says increment all the values in this range. And he also says increment all the values in this range. Maybe let's make it small, in that range. And now from that line of code from before, we construct Q So we add 1 here, we subtract 1 here at r plus 1 for that first range. And then for the second range, we add 1 here, we subtract 1 there. And then we construct p as the prefix sum of this. So now it's 1. We take these two numbers, we add them together. It's 2. These two numbers, add them together. We get 1. This one is 0 because we initialized it to 0. So we take them together, we get 1. And then we get 0 because these add to 0. And now we have 1, 2, 1, 1, 0, which is what we want, right? That's what we wanted from these ranges. So that's kind of how it all ties together. Does that explain why? So I get what you're thinking with r minus l plus 1. It's kind of, we want to increment all these values in this range. But what we've kind of done instead is we've just put a 1, we've just incremented by 1 here, and it carries over across that whole range because of the nature of this prefix sum, which adds everything before it.